So one of the big omissions, I suppose, thus far has been discussion or any kind of really detailed discussion with software that has been processing text. So we've had a lot of stuff about images and endoscopic images and how we can make diagnoses and classify endoscopic images. But of course, we all spend our days swimming in text, whether it's on paper or in electronic format. And most of our endoscopic reports are condensed or filtered into text-based form. So obviously, many of us will spend most of our day doing this, endoscopies and taking tissue. And of course, this gets reported often separately in different reporting systems. And when I first arrived at St. Thomas's, because some people knew that I'd had some facility with processing large data sets in other parts of my life, they came to me and they asked me questions. How many endoscopies am I doing? How good am I at endoscopy? When should all of these patients be followed up? How good is our surveillance protocol? And the questions kept on coming, and initially I tried to sort some of these things out, but in the end, such was the burden of questions that I thought it was better if I just kind of took a step back and tried to classify all of the things that people were asking. And in fact, you can fit most of the questions that we have in endoscopy and most of the questions that we ask of our endoscopic reports when we look over many hundreds of them into 4 silos. So first of all, we're interested in procedure quality metrics. How good am I as an endoscopist at endoscopy using whatever KPI or whatever metric you want to use? What are my diagnostic yield metrics? In other words, am I taking enough biopsies to detect this kind of problem in this kind of condition? Am I following up patients appropriately, either based just on their endoscopic findings or endoscopy with demographics or endoscopy with pathology and so on? Depends on the condition. And finally, we have operational questions. How many endoscopies am I going to be doing next year? What percentage of my patients are going to need EMRs, et cetera, et cetera. So these are all important things that we want to know, we want to ask, but we don't necessarily have the facility to do them, particularly as jobbing gastroenterologists or clinicians. And so it became obvious to me that actually, for most of the things that I want to ask, I have to consider not patients, but patient episodes. And as long as I can associate a patient's endoscopic episode with a patient's pathology episode, in other words, pathology taken from that endoscopy, and kind of line them up on a spreadsheet, then I can answer all of these silos, and anybody that comes to me with a question, I can answer just using this organization of the data. So I decided really to try and tackle this in a more formal way, and I spent a little bit of a while learning some basic natural language processing and programming a piece of software in an openly available software language called R, which is all open source, and developing this open source software. So one of the other things that we haven't really mentioned here is open source. Everything that you see here that I've done is open source, so you are able to download the code and the software now, if you like, and start to use it. It's open, it's freely available for anybody to contribute or, in fact, clone and use themselves. So this is the user interface. The development of the user interface was a pretty good learning curve in how to develop software in general and how to develop user interfaces that I like to use. I've tried to make it as click-free as possible, but under the hood it does a lot of things that I'll tell you about in a minute. The setup is essentially that you have some text. You go to the first tab, which is just a clean and merge tab, I've called it. You upload usually a spreadsheet or a lot of text that you have, which represents the text report. You upload that. You upload the spreadsheet of pathology results that you might have. You press this button and it will merge it based on shared identifiers and dates which it manages to match. And then you map the columns so that the software understands what each of the columns that have come from that merge mean. And that's a once-only setup. So when you then have new data sets, you can then plug them straight into software without having to go through the setup. And then once you've done that, it will extract from all of your endoscopies the diseases that it thinks the endoscopies represent. So it'll extract everybody who it thinks has Barrett's based on pathology and endoscopy, polyps, colorectal polyps, inflammatory bowel disease. And it also has a tab that gives a per endoscopist report based on different metrics borrowed from different diseases. And of course, because we are imaginative and we come up with new analytics and new things that we want to understand, it'll also allow you to manipulate the data yourself using drag and drop tools. So this is a very basic example of the kind of output that you might get. So this is just on one of the tabs and just represents half of the output from that tab. But essentially, it'll give you performance metrics. So along here will be, for Barrett's, it will be individual endoscopists and the the highest grade of pathology that they detect per endoscopist. So you can, for example, compare your department. It'll give you further documentation metrics, so it can give you an idea of how well things are being documented, which is an important KPI. There are operational statistics based on, or metrics based on how many Barrett's endoscopies are being done per day, and in which rooms and so on. And then there is an individual results table, so this would be per endoscopist. It'll tell you each grade that the endoscopist is able to pick up, and then if you click on these, you'll have the individual patient reports with the pathology reports, and it'll also demonstrate the endoscopic images from that pathology report. So you have a full round-trip understanding of that individual patient for that individual endoscopist. And so the same thing is also true for demonstrated for polyps. And of course, if you like, this is very much what GRS does to a certain degree when we're looking at adenoma detection rates. So I suppose one way to consider this is kind of a sped up GRS, which is customizable and can be just used whenever it is you want to use it rather than on a 6-monthly basis. Of course, it'll allow you to come up with your own metrics, the kind of things that you want to be able to do. So you can drag any one of the columns or the variables that you've extracted onto things like row heat maps or any number of graphs that'll allow you to just manipulate yourself. And there are various drag and drop visualization tools that you can also use, so you can come up with your own metrics and understanding on a per endoscopist basis. And of course, we all love reports, particularly when they're about ourselves. So it'll generate a per endoscopist report as a personalized report based on a number of different disease conditions, showing you your documentation for particular disease conditions, how well you have biopsied, for example, in Barrett's, whether you have biopsied adequately, and what your disease pickup rate is for a number of different conditions. And then finally, and this is all obviously synthesized data, it'll generate in the report, as I've mentioned before, the patient identifier, the findings, the endoscopic findings that you have written, the pathology report that's generated from the pathologist, and the images from the endoscopy. So you can start to improve your image recognition based on the feedback from pathology, so that you have a better understanding over time of what you've biopsied. And so this last report is the subject of a grant that I've recently been awarded by the Health Foundation, who've specifically funded me to improve lesion recognition using this kind of report feedback. So NLP, I mean, there's lots of different facets to NLP. So I'm just going to very quickly show you the kind of pathway that you go through when you're trying to disambiguate and understand and extract information from text. So these are, again, synthesized data. This is the kind of data set that I often find myself dealing with. So just a raw blob of text with some headers that have been put in. Usually the headers are the same across the different types of text. And so the aim was really to try and get this into the shape that you've seen the analytics form. And so generally the way you do this is largely accepted, a largely accepted number of steps. There are simple things like tokenizing, which means splitting text up into sentences, which is easier said than done given the way a lot of sentences are written. There are difficulties around spell checking, and lots of people, because of typos or inability to spell, come up with lots of different variations on a term. There are variations anyway, so there are things like halo, RFA, radiofrequency ablation, all of which mean the same thing, but all which need to be mapped. And then, of course, there's the negative extraction, which is always a very difficult sphere. This patient, as we've seen before, this patient doesn't have Crohn's, so there's no point including that in your positive metrics. So those are all very difficult hurdles to jump over, but with the help of a lot of natural language libraries that are pre-existing, have managed to deal with. I would say one thing is that the term mapping is difficult, and this has had to be manually curated. So things like Halo and RFA, you really need a domain expert, somebody who is a gastroenterologist who understands how these variables map to one another in order to do that. And so a lot of this natural language processing, particularly the term mapping, has been driven by these manually curated lexicons. That, of course, means that if you want to use this kind of software in another sphere, you just have to change the lexicons rather than having to change the program. Of course, there's the simple, the boring stuff, but the difficult to do date formatting and date matching. And then actually the stuff that's endoscopy specific comes way down the line of processing. So things like how do you standardize the endoscopist, getting rid of doctors and professors and making sure that we understand first and second names, extracting instruments, medications, extracting events like endoscopic events such as EMRs, clipping, and where those are occurring in the GI tract. And then the cleaning of pathology text. How many biopsies were taken? What were these biopsies taken of? What was it, in fact, a biopsy or an EMR that was taken? There are the pathology text, although I didn't spend a great deal of time looking at things like the macroscopic descriptions. There's a lot of information in macroscopic descriptions in pathology that is very useful when you're starting to develop these types of analytics, particularly things like biopsy size, which can give you a lot of information as to how good people are at taking biopsies, for example. And then finally, there are disease-specific functions. There are things that you need to develop just specifically for a disease, like Barrett's esophagus, for example. There are specific functions that you need to develop in order to extract Prague scores and that kind of thing. And then right at the end, there are various facilities and functions that I've developed to allow easy presentation and analysis, much in the same way that those reports are generated. So I would say creating this software has been a very good example and a very good learning curve for me into how to develop software and how to develop software that is generalizable and reproducible. So I've already mentioned this is lexicon driven. So that's very important because it, as I've mentioned, it does mean that you can take this software and potentially apply it to other fields. Perhaps you can apply it to bronchoscopy, and it would just be a question of swapping out the lexicons and swapping in a different dictionary, but the process would be the same. It has been designed to be as modular as possible, so the components can be just swapped out and swapped in. So if you want to change the software in any way, by all means go ahead and do that, but you won't find it difficult to do because the rest of the program will work. You just have to swap in different aspects of it. This has been specifically designed for endoscopy and pathology. So in other words, the extraction of information, extraction of terms has been constrained by the domain that I'm working in. And that, in fact, makes it a lot easier to extract useful information and extract metrics from that. So all of this is freely available. You can, in fact, look through the individual functions and find out what they do. You can use them yourself on freely available open source platform. One of the more difficult aspects of it has been validation. So I've been keen to validate each and every function as we go, and as most software, it's an iterative process, so that the validation will continue to be an important part of the work. And of course, the future work, and there's always future work, will be to refine some of the natural language pathways that are used, increase the size of the lexicons to cover more different aspects of endoscopy, perhaps try and tackle things like ERCP, which is a very different beast altogether. I'm quite interested in OPCS4 development, so automated coding of endoscopy procedures to have more accurate remuneration for the kind of things that we do. And of course, the user interface can always be made better and always be made prettier. I'm not really a design person, but certainly that's an aspect that I think would be more compelling. And then, of course, reusability for other subspecialties I'm very interested in. I don't think there's much point developing software if you can't think of some kind of generalized use for it and some reusable use for it. So I've just added this, I think, almost last slide, simply because I know there's some National Endoscopy Database people in the audience. So I've always envisaged Endominer to be a kind of a local thing. So perhaps coming straight out of endoscopy software. And the idea has always been to provide aggregate information. I think, as we've mentioned before, it becomes dangerous when software tries to do things for individual patients, because then you start to get into an ethical, a moral minefield of who's to blame if something goes wrong. But you're in a safer sphere when you're trying to output aggregate information. And of course, natural language is inherently error-prone, so outputting aggregate metrics is a safer space to be. So I'd always envisaged this as outputting aggregate information. Perhaps that aggregate information could be centralized so we can get national statistics and so on, and then that can be fed back. But of course, there's no need to constrain ourselves like that. The National Endoscopy Database already asked for people to upload individual patient data without identifiers, but it doesn't upload natural language, as far as I know, at the moment. But perhaps if that's something that is going to be developed, Endominer may have some usage during the centralized analysis that the National Endoscopy Database utilizes. So that's hopefully a kind of a good summary of the kind of uses that I've used for the software that I've developed. I'm very keen for it to be used as much as possible. I'm very keen for it to be as broken as much as possible so that I can understand the areas that need to be improved. So please, if you want to, if you're curious, please download it and give it a go. Thank you very much.